All right. Hey, everyone. Good afternoon. So my name is Anil Murty, and first off, I want to thank Distributed Global for giving us this opportunity to talk a little bit about Akash today, and thank you all for coming. So to start off, I'll start with a quick introduction to myself as well as the team that I represent. So my name is Anil, and I'm the head of product over at Overclock Labs. And Overclock Labs essentially is the company behind what hopefully many of you know about, which is Akash Network. So Overclock Labs was founded by Greg and Adam back in 2016. And for those of you that haven't met him, Greg is right there in the audience, and he's going to be on a panel later today as well. So Overclock Labs created Akash Network back in 2016 with the idea of trying to monetize unused capacity within data centers around the world. And more recently, we've been focused on trying to build what we're calling the open cloud for both Web3 and more recently for AI. I've been with Overclock Labs for about a year now. And prior to that, my background is 2 decades of work in the tech industry, both on the engineering side as well as on the product side. So in terms of an outline today, I kind of want to do basically 2 things. I want to give you all a general overview of Akash for those that are not familiar with it, or for those that have heard of us but do not quite know exactly what it does. And then I want to talk about sort of what our product strategy and go-to-market strategy is going forward into 2023. But before I talk about our product strategy, what I want to do is spend just a couple of minutes talking about our perspective on what we see the AI landscape today, because I think it plays really well into what we're thinking in terms of where we want to go next. So to start with, a quick overview of Akash. So this is what today's traditional public cloud infrastructure looks like. We call it traditional because we think we're the next generation of this. But essentially what you have is you have a single large entity that owns all the infrastructure, and you have thousands, if not millions of users connecting to this one single entity's infrastructure. And this is an amazing model because over the last 15 years, what this has done is it has really accelerated the rate of innovation among startups. So back in the mid 2000s or 2005 timeframe, when there was no cloud infrastructure, you'd obviously spend a ton of time and money trying to get your startup up and running. And now you can do that relatively much quicker using public clouds. So that's awesome. But what's the downside with this? The downside with this, obviously, is that because this one single entity owns all the infrastructure that you use, you're kind of tied to that. And so if they change the pricing on you, you're pretty much stuck with it. Or if there's something that you don't like about them, it's a pain to move away because there's a cost associated with moving your data out of them as well. And then at the end of the day, if they decide that they don't want your application running on their infrastructure, they can boot you out. And they've actually done that in certain instances of crypto, as well as certain politically affiliated apps that hopefully you know about. So that's public cloud infrastructure today. So let's think about if you had to reimagine public cloud infrastructure and sort of try to solve some of those problems while retaining the advantages of public cloud. How could you do that, right? So the most simplest approach to that would be to take this one single infrastructure entity and essentially split that among many different entities that own the infrastructure, right? So you've taken this one single entity like AWS, and instead you've split it across many different entities that own a little piece of this entire infrastructure. Sounds great in theory, but in practice, this doesn't really work. So why doesn't it not work? So the reason it doesn't work in practice is because, number one, if you're a tiny startup and you're trying to deploy infrastructure across multiple different entities owning, or trying to deploy applications across multiple different entities owning this infrastructure, you need a fairly sizable DevOps team. So you need a team that's capable of understanding how to deploy onto provider 1, onto provider 2, onto provider 3, so on and so forth. And that's not something that a small team can afford. Next, you need lengthy negotiations and contracts with each of these different data center companies. So if you're hosting your infrastructure in a co-location center, then you need some sort of a contract there. And there's a capital expenditure cost associated with that as well. So at the end of the day, this makes it a really high touch and high capex sort of situation. And that's where the public clouds really flourish. And that's what keeps people going back to the public clouds, right? So to substantiate the thesis I'm driving here, there's a chart on the right here that you can, if you just Google data center companies over time, you'll probably find this chart on the web. It basically shows the number of data centers in the world over time. So what you can see from this chart is that there's been a decline in the number of data centers, and these are basically independent data centers, not public clouds. So while the decline is kind of sad to see, at the same time, what you can see is that there still are a sizable number of these data centers across the world, right? There's still over 7 million of these. So any solution that can sort of leverage all the compute power that exists within them is a good solution to have. And moreover, many of these data centers only utilize about 20 or 30% of their capacity on a given period of time. So the rest of it pretty much sits idle. So they're open to giving out that capacity at a significantly lower cost, and that benefits both of them. So this is where Akash Network comes in with what we call our decentralized approach. And so what we've done is we have basically taken that idea and we've built something called the Akash Marketplace for cloud compute. So the Akash Marketplace for cloud compute is essentially a software abstraction layer that sits between the users and the infrastructure providers. And we refer to the users as tenants within the Akash construct, and then we refer to the infrastructure entities as providers. And so essentially what you've done is you've solved that problem of the need for a homogeneous deployment solution. So regardless of which provider you're using, you as a tenant or a user always get the same look and feel and the same kind of deployment workflow, and you don't have to worry about where the provider is. And then further, by leveraging a blockchain, essentially our own app chain running on Cosmos, what we're able to do is we're able to negotiate these leases really quickly and store all the lease information on the blockchain. And so that's how we leverage a blockchain to solve that problem of a lengthy contract negotiation process and having to do that over and over again. So that's essentially the Akash Marketplace for cloud compute. Some people fondly also refer to it as the Airbnb for cloud compute, and you can see why, because it's essentially a two-sided marketplace. On the one side, you've got users, and the other side, you've got providers. Okay, the other thing about Akash is that it's built entirely on open source software. So the two most popular and most widely used open source solutions out there, one of them is Kubernetes, which is essentially a container orchestration solution. And then the other is Docker, which is probably the most widely used Docker container solution out there. So pretty much all the tenants or the users that deploy onto Akash, they deploy using Docker containers, and then all the providers run Kubernetes clusters. Not only do we use open source software, but then we turn around and we actually make all of our software open source as well. So on the left side of the screen is a screenshot of our GitHub repository. You can go to it at github/akash-network. And what you can see is that there's a repository there called the node repo. That's basically our client repo, the provider repo, and then console, which is our deployment tool. And then last but not least, we also have a community repository. And what that is used for is essentially for developing everything in the open. So at the start of this year, what we decided to do is we decided to take the next leap in the development of our project. And we said, not only are we going to be open source, but we're actually going to do everything in the open. So we literally have what's called the equivalent model of Kubernetes, where we have the concept of special interest groups or SIGs, which are essentially these vertically aligned groups that are focused on things like providers, on deployments, on clients, on the chain, so on and so forth. And then we've got these horizontally focused groups called the work groups, which might be working on something like GPU support, which requires both changes on the provider side as well as on the client side, and maybe some go-to-market and community activities. So that's the idea here, is everything is in the open. You can find it on our GitHub repo. There's also a list of projects that we're working on, if you go to the GitHub repo on the right side there. And the sort of traction from the community has been amazing. There's a few charts here from one of our repositories, and you can see like the trend in terms of the number of people wanting to contribute to this, wanting to come and check out what's going on, has been sort of skyrocketing in some ways. Cool. So just one slide really quickly to dive into what the deployment workflow looks like in Akash. I don't want to make this overly technical. But essentially, the way it works is that you, as a user or a tenant, you take your application or workload that you want to run, you containerize it into a Docker image, and then you create something called an SDL file. So SDL stands for Stack Definition Language, and it's basically the way that you specify what compute resources your application needs in order to run, right? So this would include things like compute needs, which is memory, CPU, and storage, what sort of locations you would want this to be deployed in, any other attributes that you might want from the provider. And then last but not the least, you also get to specify pricing, which you don't get to do in the existing public clouds. So once you submit that SDL to the marketplace, that's called requesting a bid. And then depending on the attributes that you set, you get a set of bids back from the marketplace. So today in the Akash Marketplace, there's a little over 50 providers. And so you might get 10 bids or something back from this marketplace. And then you choose the kind of bid, the kind of provider that you want based on your price and performance requirements. So like how much do you want to pay versus how much performance do you want to get. And then once you click the second set of actions, Akash goes ahead and takes your deployment, creates a lease for you, and then deploys your app on that provider, and your app is running in a few minutes. It sounds pretty complicated, but this typically takes like a few minutes end-to-end to run. Okay, so that's how Akash works in a super high-level nutshell. But the benefits essentially to the user, just to sort of recap what I said in the last several minutes, is number one, there's a significantly lower cost for the reasons that I mentioned before. So here is a quick comparison of Akash for some of the standard types of memory and CPU and storage requirements that people use the various cloud providers for. And it actually comes from one of our ecosystem teams called CloudMoss. There's a URL on the side and over there. And you can see that it's significantly lower, up to 80% lower in some cases. There's obviously greater choice, because as the number of providers increase, you get more locations, you get more pricing options, you get more attributes within these providers, the types of vendors they use for their CPUs, so on and so forth. It's self-sovereign, meaning like nobody can kick you out. It's open source and community-driven, as I talked about in the last slide. And then last but not the least, it's powered by blockchain technology, because that's what enables us to do these really fast leases between the tenants and the providers. Cool. So I talked about what Akash is today, and hopefully it gave you a sense for what we've been up to the last several months, if not the last whole year. What I want to do next is spend just a few minutes talking about the AI landscape as we see it from an Akash perspective, and then jump into our product strategy. So there's obviously been a lot that's been going on in the AI world in the last, since the start of the year, pretty much. But I try to sort of boil it down to 4 things, at least from our perspective. And those are kind of on the slide here. And essentially it comes down to new models being shipped all the time. This race, seemingly a race to the bottom with people trying to produce equivalent apps on top of OpenAI's APIs. In many cases, they're doing exactly the same functions with very little differentiation. And then this seeming scarcity of GPUs, which everybody seems to want to find and can't seem to get their hands on. And then last but not the least, like how is open source doing in all of this, given OpenAI's stance? So talking about the first 2 things, obviously, there's been a ton of new models that have come out since the start of the year. But the 2 things that stand out for us specifically is, number one, there have been a number of variants of these foundational models. And these are basically people taking these foundational models, using some sort of limited data set, and producing a variant of it. So, something like Alpaca or GPT for all, for example. Those are good examples of those. And then another thing that is really sort of stands out for us is basically this idea that enterprises today are starting to look at taking some of these foundational models or making their own models and training them with a data set that is unique to them, right? And so it's a much smaller data set, and it's focused. And so all this is just going to say that there's going to be a need for people to not just run inference using APIs from OpenAI, but training their own models and running inference with them or fine-tuning them, right? And then on the right is this race to the bottom with all these OpenAI API clones. And the way I see that going, or the way we see that going, is there's going to be obviously consolidation with a lot of these disappearing over time. But there's going to be a few that stand out and are able to differentiate themselves by fine-tuning the existing base models to produce something that is different. And all of this drives demand, basically, for compute. Which brings us to the next thing, which is, the way I like to put it is, GPUs are essentially the new oil in some ways. So if you guys follow our Twitter or keep track of what's going on in Akash, you probably saw the announcement a week ago where we announced support for GPUs on our network. And we launched a testnet for that. And you can see there's been a significant amount of interest from the community. One of the tweets there on the left is from one of the core Bitcoin developers who's really excited that we have GPU support now. Because we have heard from many of these people in the mining community that want to get their mining rigs that have sort of been turned off after the switch to proof of stake onto the Akash network and utilize them for AI workloads. And then there's a tweet by, I believe, the CEO of Latitude, who is excited about getting H100s onto the Akash network. And for those of you that are not familiar with what an H100 is, it's basically the latest generation chipset from NVIDIA that literally none of the clouds even have today, none of the big clouds have today. And rightly so, they're excited about it, rightly so, because if you look at the GPU stronghold today, all the big tech companies essentially hold a bulk of the GPU capacity in the world. And Elon Musk is the latest one to enter that race, and he's reportedly purchased billions of dollars worth of GPUs to start building something within Twitter. And then last slide here is basically the projected market growth rate for GPUs over the next 10 years. So the estimates is it goes from 40 billion today to about 400 billion over the next decade. So that's a pretty big TAM, and if we can carve out a small portion of it, it's a good business to have. Cool. And then the last one I want to touch on is the open source, state of open source within AI. So initially when ChatGPT came out and then OpenAI started to make stride after stride every week, for a brief moment it felt there that it's going to be like a winner-take-all situation where OpenAI takes everything and there's basically everybody's just building on top of them. But it's nice to see that open source has really picked up in the last couple of months. So there's examples from Stanford team that has taken Meta's Llama model, which is open source, and produced a version that can run on a laptop. And in fact, I've run it on Akash's CPUs, and there's a tweet I can point you to that shows you a demo of that. And then there is also tweets from the folks over at Hugging Face, as well as Stability AI, talking about how they're very focused on being open source. Cool, so with that little bit of diversion towards our AI view, I want to spend a couple of minutes talking about our product and go-to-market strategy. So long-term vision for Akash pretty much remains the same as it was for the last several years, if you followed us. Our long-term vision has always been sort of to try to get to cloud parity with the other clouds that exist today. So if you think about trying to get to cloud parity, one way to think about that is to make this huge laundry list of all the features that these clouds support today and just start checking off each one of those, right? That's one way to do it. A better way to do it is to say, what are the specific user segments that we can reach as a community today, and then focus really hard on trying to make the best user experience for those user segments. And then if you solve those user segments, not only do you generate demand and grow as a community and as a company, but then you also achieve cloud parity, because if you solve it for them, you're probably solving most of the cases for general web services. So those three user groups that we've identified at this time are basically, number one, blockchain nodes, for the obvious reasons. Number two is general web services. So this includes things like static websites, slightly more complicated web services, and then of course AI and ML with the introduction of GPUs on the Akash Marketplace. And then in terms of how we want to get to market, it's a really straightforward strategy, which I don't think is new to anyone here, but essentially we have a product that the core team has built. It's a deployment client called Akash Console, and that's a screenshot of Akash Console. And our idea is essentially Akash Console is this thing that we use to demonstrate the capabilities of Akash. So if you produce GPUs, we demonstrate how AI workloads can be deployed onto GPUs. If we produce some other feature tomorrow, that would potentially result in some kind of thing being built within Akash Console that should showcase that prowess of Akash network. And so the idea here is we demonstrate capability within Console, and then we work with partners to go to market. And these are the partners that really will scale the solution, will take it to market, and sort of make Akash network really popular out there. So in terms of the partner strategy, again, like we have a growing list of partners that we work with. On the left is a set of ecosystem teams that are actually building solutions on top of Akash. So I list Akash Console as one of them because it's technically an open source product at this point, and there's a community of people working on it that are all open source developers, with a couple of folks from within the Overclock core team. But then there are all of these other solutions as well for client deployment. So there's like a solution called Fleek that is focused primarily on the React user base, making it really easy for React developers to deploy onto Akash and others. There is a Terraform provider for Akash. So if you're a developer, a DevOps engineer, or an operations engineer, you know how prevalent Terraform is today in the world of operations. And so it's really important that we have a Terraform provider. And so a team has gone and built that. We have client libraries being built for Java, for Python, for various other programming languages. And then we have teams working on deployment clients that work in the web UI. And in fact, I think Prashant from the Spheron team should be somewhere around here. And I think he has a talk later today where he'll talk about what they're working on. Outside of deployment clients, we also have UI being built for provider onboarding and management by a team called Praetor. And so they have built a really easy tool for setting up a provider on Akash. So you can use, of course, our command line tools and our Helm charts that come from the core team, but you can also use this UI-based method that runs in a browser to set up your provider if you want to be a provider. And then we've got Murty audits who are responsible for auditing providers. So when a provider comes online, they check out the attributes that the provider is claiming to have. So if a provider claims a certain amount of CPU or memory or bandwidth, they go look at those things. And then on the right is certain partners that we're working with to integrate with and sort of be like these aggregators for things. So LavaNet and Pocket are good examples of companies that have become aggregators for RPC nodes and for validators. And so we're working with them to see how we can make Akash sort of the default place that all that infrastructure runs. And with that, I'll kind of end on this mission statement. And I got to say, I came up with this mission statement just a couple of days ago. So, and I ran it by our CFO, also acting CMO, Cheng, who's out there, last night. So he approves it. He did approve it after, I think, like, what, 3 wines and a little like dim light and showing you this on my phone. So hopefully it's good. But yeah, I feel pretty passionate about this because, if you think about it, as the demand for these super high-end chipsets and GPUs increases, there's this mad dash to go and just buy a lot of these GPUs. But if there's a solution that can make the existing GPU power that's, for example, in the mining community, there's been miners that have used legacy NVIDIA RTX, GTX type chipsets for years for Bitcoin mining or Ethereum proof of work mining. If we can find a way to match that supply with the models that are being optimized now, running on less than super high performant GPUs, that would be a win-win in terms of making a sustainable solution for AI innovation. So that's kind of my pitch there. And if you want to connect with us, here's a few ways you can do that. Obviously, I have a Discord. You can try to deploy an app on Akash. It's super easy to do. You can choose to become a provider. Or if you're a team that's building things on other similar decentralized platforms, we'd love to talk to you. And then if you want to reach out to me, my Twitter handle's there as well. And that's it. Thank you.